So hi everyone, how are you guys doing? So first of all, let me welcome you guys to the Unacademy JEE English. This, as you know, is a brand new channel by Unacademy where every concept of physics, chemistry, and maths is being taught to you completely in English. So hi, I'm Mohit Kumar. How are you doing? All right. So this is a series that I host for class 12 student or any aspirant who is looking to take their JEE examination in the 2021. Okay, for the mains. Yeah, and the topic that we are discussing right now is called thermodynamics. We are going through a quick review of different topics where we are quickly revising some key concepts and practicing some previous year problems. So this is part two of the quick review of thermodynamics. And before we get started, let me introduce myself for those of you who might not know me yet. So my name is Rohit Dixit, and I studied mechanical engineering from IIT Delhi. And for almost past 8 years, I have been teaching physics for the IIT JEE Mains and advanced examinations. So as a student, I myself was All India rank 447 and All India rank 192 in the two stages of the IIT JEE exams that I took. And I also qualified the NTC stage 2. I was in the top 1% in the NSCP. And I have coached many students to top ranks in the IIT JEE examination so far in this long career of mine, which had been in offline institutes. So offline, I was associated with some of the topmost institutes that you have heard of. And there, I've already coached many students to top ranks in the JEE Mains and advanced examinations. Now, I am hoping to continue doing that online here with you guys. So as I said, this year has forced all of us to adapt, to look at a different new means, okay, towards, carrying forward with our lives. So just like that, as students, what you guys can do is just to carry forward with your JEE preparation, you can get yourselves the Unacademy subscription. Now, this subscription will give you benefits like live classes where you get to interact with your educators. Then in these classes, you have live polls and leaderboards, which keep them highly interactive and fun. And of course, you have live tests. You have test series and analysis sessions, again, which keep you completely aware and on your toes throughout your preparation, which is very important for a competitive exam like JEE. And of course, you have live doubt clearing sessions. So as a matter of fact, all the Unacademy Plus courses have this feature. So hi B Kaushik, good evening to you, family home. How are you guys doing? So all the Plus courses of Unacademy have this feature that every fourth session is compulsorily a live doubt clearing session. So after every three teaching sessions, you have an entire session dedicated to your doubts where students can ask their doubts related to theory, related to problem solving, and power ahead in their preparation for their JEE examinations. And on top of all these benefits, now, of course, the biggest benefit of all is that you are getting the chance to study from the topmost educators all across India from the comfort and safety of your home. So that's a wonderful opportunity, I think, which you guys can utilize and make the most of it. So how do you get this subscription? How do you get avail all these benefits? So the first step includes, of course, to install the Unacademy app. Now, the moment you do that, you will already unlock a lot of free features which are available on the Unacademy app. So these features would include free courses. So there are some free courses which you can simply register in just after downloading the app. Plus, you have special classes. So all the teachers keep taking special classes on the Unacademy app, which are completely free for students. Okay, so like today, I have one practice session, special class planned. Okay, so you can be a part of that from 6:30 to 8. Okay, and of course, you have free quizzes. So all these features you can simply unlock by installing the Unacademy app. You don't even need the subscription for this. So this will already give you a flavor of how your plus experience is going to be. Now, when you're convinced, okay, and if you like what you see, and when you finally decide to get yourself the plus subscription, this is what you can do. You can go to the plus section of the app, select your goal as IIT JEE, and click on that get subscription button. Now, that is it. That is how easy as it gets. Okay, once you do that, you'll be redirected to the payment page, wherein you will find a box which will say, "Do you have a code?" Now, in that box, don't forget to use this code RD Live. This is my code. This will give you 10% off on all your subscription fees. And let's talk about that. Now, when you notice the subscription fees are already very competitively priced. So 12-month subscription actually comes at around 2,800 a month, and the 24-month subscription comes to about 2,100 a month. So trust me, students are paying more than this for their class 5th and 6th tuitions. So you're getting a wonderful opportunity to study from the topmost teachers all across India for the most competitive exam probably in India, and at a very reasonable and affordable prices. Now you'll also realize now you can choose from two kinds of subscriptions, either Plus or Iconic. And when you click on Proceed to Pay, you have a lot of no-cost EMI options, which will take care of the fact that you do not feel the burden or pinch of this payment also. All right. Hi, JEE aspirant. How are you? Further, moving forward, let me just quickly tell you a bit about the iconic subscription also. This is something new. A lot of students do not know about this. The iconic subscription is something which will take your IIT JEE preparation to the next level. How? So you'll be assigned personal coaches. So that is an interesting thing. So these personal coaches will closely mentor and guide you to through your IIT journey. You will also be attending a lot of IIT JEE workshops. So this is along with all the plus courses and the plus features that you have. So you will be receiving expert guidelines from time to time. You'll be getting a study planner, which I think a lot of students can use. Okay, and then you have regular test analysis sessions. All right. So along with these features, as I said, your JEE preparation will be taken to the next level. Okay. So family home says that today I encountered a question and I have a doubt in it. Okay. Can I ask? It's a question in Irrido mechanics. If you want, I can type the whole question. I did saw the solution online, but I have doubt in it. Okay, sure, go ahead, go ahead, yeah. Anything. Of course, the reason why I'm here is to help you guys out. Okay, so not a problem at all. So go ahead, give me the question. I do have the Erudo right here with me, by the way. Okay, as a matter of fact, so I have it. I always have it lying around. So even if you can tell me the question number, that will also do. Okay. All right. Anyhow. So however you want to share your doubt, not an issue at all. All right. So as I was saying, so now let me also tell you about the Unacademy Combat. So if you don't know about this, this is the most competitive gamified IIT JEE battle. So here you have a chance to test your knowledge, see your standing amongst your peers, and if you do well, you can win yourself some really cool rewards and prizes. Okay, so these prizes include a lot of gift vouchers and even year-long Unacademy Plus subscriptions. Okay, so the next event is going to happen live on the 3rd of January, and you can enroll now using the code RD Live. And if you do well, again, so as I said, you can win yourself some really cool prizes. For those of you who are following us on the JEE English channel of YouTube, can connect with us on the Telegram app using this link so that you're getting all the notifications and you are aware of all the amazing sessions and lectures happening here on this channel. Okay, so let's look at. Oh, so that's too good. Thank you. No problem. Mechanics question number 107. Okay, so let's take a look. So the good thing is that this book hasn't changed over the years. So the version that I have is a very old one, I think. Yeah, but over the years, yeah, I have wow. I have the 2000 edition, year 2000 edition. I love this old edition. I think I found this lying somewhere in my hmm, books. So this is something that I saved all this while. This is something that I probably saw when I was a student. Okay. So problem number 107. Let's see. A chain of length L is placed on a smooth spherical surface of radius r with one of its ends fixed at the top of the sphere. What will be the acceleration of each element of the chain when its upper end is released? Okay, you have to assume that the length of the chain L is less than pi r by 2. All right, so that is one interesting question. Yes, I can see why you would have troubles with this. Okay, so what maybe I can do is maybe I can just add a page here and take up this problem. So this is a very interesting problem. Fact, a tough problem, so to say. All right, let's see if do this. All right, so what you have been told is that you have a sphere, right? So let's imagine for the time being smooth spherical surface of radius r. Okay, so let's make a spherical surface. Okay, so here we go, and you have a chain which is hanging, which is attached like this. Okay, from the top, and has some length which is less than pi r by 2. So that means it will cover less than quarter of the sphere, right? This is the part. Let's say this is the circle here, and this is the center. So here you have your chain, which is attached something like this. Okay, got it. Now it's saying it is initially fixed at the top, and now the connection at the top is removed. So it will slide over the spherical surface, and you have to find the acceleration of each of the element. Okay, So now the trick is, okay, so there are three ways of doing this. There are three ways of doing this. Okay, so one is if you know this should be a frictionless surface if I'm not wrong. Where is it? So one way is you find the net tangential force at any point. Okay, and then integrate the net tangential force and then find the acceleration. Yeah, smooth spherical surface. Okay, so smooth spherical surface and that's it. So what you can do is so first of all you can find the tangential force acting on it. So if you realize that at every point if I consider some small portion of this, right? So let's go from here at an angle theta and let's consider this portion which is spread across a length of d theta, right? If I consider this. Now, the forces that this portion would be feeling would be internal tensions, okay, and the external force of mg. Okay, so if in the tangential direction, if I have to look at the net external force, so the net external force would be the component of mg only. Okay, okay. So one trick is that if you know, I have discussed this in my classes, right? So that even when you have these kind of problems, right, pulley problems and something like this, so where you have two masses. Okay, so what I did was, sorry, what I did was, if you see what are the forces, external forces that are causing the motion. So if you talk about the external forces that are causing the motion, so external force that is causing the motion here is m1g, and the external force that is causing the motion is m2g. So the net external force causing the motion would be m1 minus m2g, and the acceleration of this would be over the total mass of the system. Okay, so this was the trick that we used to do in solving pulley problems, right? So we can use a similar kind of an approach. Okay, green is not visible. Oh, yeah, yeah, yeah. Should I change the background color to white? I thought some people preferred black color. So you tell me, should I change the background color to white, or do you prefer black background but you prefer some other color of the pen? Okay. So what we will do here is, similarly we will find the net external force which is trying to cause the motion. Okay. If I focus on the net external force that is trying to cause the motion, so let's get rid of this. Okay. So for this portion, I will realize that for this portion there is an external force. So okay, let's use brighter colors maybe. For this particular portion, if I talk about, okay, I hope this is visible. So if this has some mass dm, okay, dm, then the force, external force on this would be dm times g, and the tangential component can be calculated. This component would be trying to cause the motion. Okay, this component is what I'm interested in. Okay, you might use white to write. Okay, sure. Okay, I'll do that. Right. Now, if I notice that since this angle is theta, this angle will also be theta. Right. So this is 90 minus theta, and this will also be, okay. So this will be 90 minus theta. So I know that this component is nothing but dmg sine of theta. Okay. Do you agree? This will be the net tangential component. Now theta is varying. Theta is varying. So that is where I have the problem. Okay. This component is going to vary all the time. So if I can find the net magnitude, so all this, as long as the mg components are tangential, all of them are trying to cause the motion, right? So they all are pulling the chain and causing the motion in one direction. So I won't actually add them like vectors. I will just simply find the net magnitude of the force causing the motion. Okay. So let's do that. So I can say df external causing the motion. Okay, that is dmg sine of theta. Correct. I don't know if that's visible. Okay, maybe I can write it below slightly. So what I can say is df external, which is trying to cause the motion, can be written as a dmg sine of theta. Correct. I hope that is should be visible. 5K subscriber says, sir, use digital board as soon as possible. Okay, so using a digital board is not up to me at 5K subscriber. So I have asked the Unacademy team. I don't know how long will they take. They're saying so. There is a lot of problem regarding that. I, uh, so I don't know. I don't know. Whenever it is possible, definitely I will try and use that. All right. So if I can say that. So for the net external force, all I need to do is integrate this component, and I'll integrate it like scalar because I'm only interested in the net magnitude of the force causing the motion. Okay. So I can say F external causing the motion. This is the F external causing the motion. Okay, so that would be dm. Dm can be written as lambda times r d theta times g times sine theta. Correct. So all I need to do is integrate this, and theta will go from 0 to, let's say, the net angle subtended by this is some alpha. So 0 to alpha. Okay, so if I integrate that, let's see what I'm getting. F external is equal to, so all these are constant. So lambda, r, g, all of these will be constant. The integral of sine theta would be minus cos theta, right? Minus cos theta, and then I would have 0 to alpha. So what I'm getting is if external net is lambda r g 1 minus cos of alpha. Correct. I will also realize I can say alpha would be the arc length over the radius. Correct. Now all I need to do is for acceleration A would be F external, which is the net external force trying to cause the motion over the total mass. Okay. So Rahul sir taking digital board only, sir, now. Okay, sir, thank you. So, but in the integration of external, the direction of external is changing at every point. Absolutely, absolutely. But I am only taking the tangential components which are causing the acceleration, right? Which are causing the motion. At any point, what is happening is only the tangential components of the mg are causing the motion, right? So all of those can be simply added together. Again, if you remember that pulley problem, what we used to do is, I would tell you that what you can do is, okay. So let me first finish this solution and then I'll let you know. So m would be nothing but lambda times L. So that is what I will do. R G over this will become lambda times L. And here I will have 1 minus cos of L over R. So this becomes the answer. Acceleration is Rg over L times 1 minus cos of L over R. Okay, I will show you another solution also. Okay, first let's finish this. And then I'll tell you the logic why I did not consider the direction. Okay. So let's see, 107. Do we have this as the answer? Okay. Hmm. And then I will tell you that. Don't worry. So what is happening is, so let's see. Yeah, that is the answer. All right. So here first we got ourselves the answer. Now I'll tell you why I did not take. Yeah, I know. Now let me tell you why I did not talk about the direction. That was because. So if you remember, uh, okay, if you remember the pulley problem, if you remember the pulley problem. So what I told you was that the reason why you can solve it as the net external force causing the motion over the total mass is that you imagine this to be like this. You imagine this to be like this. So one portion is being pulled at one side with M1G and another portion is pulled in the other direction like M2G. Okay. So you realize the acceleration in this situation and in this situation will be the same. So these two are equivalent of each other, right? These two are equivalent of each other. You understand that? The acceleration produced in this case would be identical to the acceleration produced in this case. You think there is any reason why the accelerations would be different? So that is why I can consider the net force causing the motion and divide it with the total mass. It's very similar to that. It's very similar to that. Okay. The idea is that so, so when you have this chain, let's say like this. Okay. See, let's use brighter colors. So when you have this chain, if you look at different parts, So the external force that is trying to cause the motion on this one is dm times sine, let's say here the angle is some theta, okay, and here the angle is theta dash. So on this portion, the force that is trying to cause the motion is dm times g times sine theta dash. So what I can do is I can imagine this chain was straight and every portion was feeling a different force. So this guy would be feeling its own dm times g. Okay, this guy would be feeling dm times g sine theta dash, and this portion would be feeling a force which is dm times g sine theta. Okay, so do you understand that? And this portion, of course, is feeling zero. So all the forces that are acting, if I can just straighten this out, they are all acting in the same direction. Just their magnitudes are changing. So I can imagine this to be equivalent of this. Okay. Do you follow the logic? Okay, if you do not like this, then I will show you another way to solve this. I can show you another way to solve this also. Okay. First of all, the idea is you can always find the acceleration by finding the net external force causing the motion over the total mass. Okay, okay. Right. Now let me tell you another way also, which will not leave any doubt in your head. Okay, now let's consider another solution. Okay, so yeah, let's add another page. Let me show you another way of solving this. So this is one way of solving which you will find given at places. Now I will solve this using another method, and trust me, that will not leave you any doubt with any doubt. Okay, so you just need to be aware of the fact. You just need to be aware of the fact that if I talk about this portion, if I talk about this portion in the overall chain, what will be the tension at the ends? Can you tell me what will be the tension at the ends? Okay. So what will be T here? Let's call it T1 and let's call it T2. Can you tell me the values of T1 and T2? Can you guess them? Yes, of course. Don't worry. I will show you. Can you guess the values of T1 and T2? So show, but tell me. Just take a. What do you think would be the values of T1 and T2 here? Just think about this. At the ends, right at the ends, what would be the value of T1 and T2? Take a guess. Take a guess. Just try and figure out. Just try and figure out if I considered a small portion here, a small dm here, only a small dm here. Towards the end of it, there cannot be any tension. Okay, so there will be some tension here. There will be some tension here, some tension dt. But on this end, at this end, there cannot be any tension, right? T would be zero. At the end of the rod, at the end of the rope, the tension would be zero. Do you agree? Then just above, if you draw the FBD of this dm, if you draw the FBD of this small little dm, so this small little dm would be feeling some mg dmg sine जो भी theta होगा यहाँ पे sine alpha, let's say, and some tension dt. It is going to be something like this, right? Similarly, if you talk about this portion, right? So this portion, if you talk about dm, so again at this end, there will be no tension. At the ends, there will be no tension. Again, if you talk about the FBD of this, then this is feeling dmg, right, like this, and it will feel some dt. dash here, and this end, on this end there will be no tension. Okay, T would be 0. So the tension would vary across the elements. In this kind of a setup, the tension would vary across the elements also. Do you agree? The tension would vary across the element itself, because this is a mass, a portion with mass which is accelerating. So the tension would vary. Okay. So you just need to figure this out, that at the ends, the tension would be 0. Okay. There cannot be any tension at the ends. You will realize that also later. You can prove this. You can prove this mathematically also, by the way. But let's just say that at the ends the tension is 0. Now let's consider a portion, small portion here, somewhere in the middle. Let's consider somewhere in the middle a portion, okay, which is at an angle of theta and subtending an angle of d theta. So theta and d theta. And let's say this also has a mass of dm. Now if I draw the FBD of that dm, so FBD of this dm, what will I get? I will have here dmg sine of theta, then I will have dmg cos of theta, then I will have some n, and let's say I have some tension here and some tension here. Okay, so let's call that some t and t plus dt. Okay, so it would feel a net upward force because the acceleration has to be less than a dmg, less than g sine theta. So tangentially, the tension on the upper portion should be greater for some part, for some part. Okay, all right. Let's just say that. Let's assume even if the tension at the other end is lower, then dt would be negative. I don't care about that. I've assumed that tension at the lower end is smaller and the tension at the higher end is greater. Okay, I don't know if that is visible. Should I draw that below? Okay, let's draw this again. So what I'm doing is I am going to focus on this portion, okay, this particular portion, and let's draw the FBD of that. Okay, so I'm assuming here it is dmg sine of theta. Then you have dmg cos of theta. Then you have some dn, a small normal reaction felt by this. Let's say the tension here is T and tension here is some T plus dt. Okay, that dt can be negative also. I don't really care. All right. Now let's try to see. Imagine if this is moving with an acceleration of a. So for this, can I say for the portion shown, for the portion shown, can I say that dmg sine theta plus t minus d would be equal to dm times a. Agreed. Great. Let's say that. Okay, so that just tells me that dt would be equal to dm d sine theta minus a. Correct. Now a is independent of theta. You know that every element for any theta would have the same acceleration. Right. So I can say a is independent of theta. Correct. So all I need to do is if I integrate this, so the tension at this theta was 0, tension at this theta was 0. So I will integrate this from 0 to 0, and the theta would go from 0 to alpha. Can I say that? Now, if I integrate this, I will get 0 here, and here I will get, okay, so integral of, well, let's say, integral of m sine theta, no, minus integral of m a. So from 0 to alpha, 0 to alpha, and what you will realize is 0 equals. So this again I will write 0 to alpha dm. I will write r d theta lambda g sine theta, and I know a is constant, so a times integral of dm, that would be ma. Correct. So what you have is ma is equal to r lambda g cos of theta to the minus sign going from 0 to alpha. So here you have the same thing again, and m can be written as L times lambda a becomes equal to r g lambda 1 minus cos of alpha. You cancel this out, and again you're getting the same thing. Okay, clear. Let me know if this is clear then. All right, so here all I needed to figure out was that the tension at the ends should be zero, right? Tension at the ends should be zero. That is all I needed. Apart from that, I don't need anything to solve this, right? And simple integration is showing me that the answer is coming out to be like this. So yeah, you need to know something extra, okay? This method just blew my mind and also made the solution clear. All right, all right, all right. Cool then, right? Okay. Great, great, great. So yeah, sometimes you have to use a little bit of mathematical tricks, some knowledge you need. So either you should have known that the net external force causing the motion over mass would be the acceleration, or you should have known that the tensions at the ends would be zero. Okay, you have to figure that out at least. Okay, once you figure that out, at least then you can solve this. Okay, no problems, no problem, family home. All right. Okay, then why don't we begin with today's discussion then? Okay, I'm glad I could help. Yeah, I know. These are some of the most confusing questions. So a lot of students can't easily figure them out. Even the solutions are such they don't really explain much. So yeah, I can imagine why you would be confused. So that's all right. Don't worry about it. Okay. Hello, Mahi. How are you? So let's get started finally with our quick review part two of thermodynamics. So today we'll start the discussion with the discussion of thermal expansion. This is a simple phenomena. So we realized last time that heat is a form of energy. So whenever you're supplying a body heat, then it will have two kinds of effects essentially, right? It will increase either the kinetic energy or of the molecules or the potential energy between them or both. Okay, so these are the possible outcomes when you add heat. So one outcome is thermal expansion. Thermal expansion is a result of increase in potential energy between the molecules. Okay, now how does that happen? So let's talk about this. So when matter is heated without any change in its state, it usually expands. Okay, according to atomic theory, asymmetrical nature of the potential energy curve is responsible for thermal expansion. So as there is a rise in temperature, the amplitude of vibration of the molecules would increase, and hence the energy of the atoms increases, and hence the average distance, and so on and so on. So matter as a whole expands. So let's try and understand what we've just said. Okay, what does this page actually say? So imagine this. Imagine this. This is the graph for potential energy between intermolecular forces with respect to the separation between them. Okay, I don't know how many of you have seen this, but this is what the graph looks like. This is a U versus R graph, where R is the separation between two molecules and U is the interaction potential energy between them. Okay, now that is what the graph looks like. Now you will notice here that if you have a certain level of potential energy, then you have two R's. So why do I have two R's, R1 and R2? Why do I have two R's for corresponding to a certain potential energy? See, the reason for that is all these molecules are constantly vibrating about their mean positions, right? you know that this is how we equate any solid. Okay, any solid structure can be seen as a collection of masses connected with springs. Okay, this again you should have studied in your solids. Okay, so what happens is all of them are vibrating. So while vibrating, when they are at the maximum separation, then the separation is, let's say, some R2, and when they are at their closest, then the separation is R1. Now, if you remember a little bit of your SHM, if two masses are vibrating like this, then you realize the kinetic energy of the masses will get converted into the potential energy of the spring at the extremes, and it will again be completely converted into the potential energy of the spring at the other extremes. So you realize all the energy would go into the potential energy at the extremes. So at R1 and R2, you would have all the energy which would be stored in form of U, and that is what this is representing. At a particular temperature, the particles have a particular amount of potential energy, so they keep vibrating between R1 and R2, and these represent the extreme points where all the energy of the bond is present in form of the potential energy. All right. So as you increase the temperature, as you give it more heat, what happens is that your kinetic energy increases, so the molecules start to move around more vigorously. Then you realize that the minimum separation would decrease and the maximum separation would increase, and hence will the overall potential energy. Okay, when you're adding energy, so overall potential energy is also increasing. But look at the nature of the graph. For U1, if this is R1, this is R2. For U2, if this is these are the two forces, these are the two distances of the extremes, right? Now you realize, because of the nature of this nature of the graph is such that the minimum separation does not decrease as much. However, the maximum separation increases a lot. So if you talk about the average separation between the molecules, when we are talking about the size, we talk about the average separation being the mean of these two. So the mean was here. Now the mean has increased. Okay. So you realize, as you provide more heat, the potential energy is increasing. So potential energy increase corresponds to a higher separation and a lower separation between the molecules. But because of this asymmetric nature of the graph, what happens is that the average separation actually increases. If the graph was perfectly symmetric like this, then trust me, you won't have seen any expansion. Okay, so why I let's just say here the energy was U. So these two would have been the minimum and the maximum distances between the two vibrating atoms, right? Now, even if you increase this, so both sides the distances would have changed equally. So the mean distance, or I can say that the average separation between the molecules would not have changed, and hence you would not have seen any expansion. But it's due to this asymmetrical nature. The nature of the graph is not symmetric, it is like this. So you realize, on one end, the change is higher. So on the this end, the change is higher. Right? The maximum separation increases by much larger value than the decrease in the minimum separation while vibrating. So that is why the average separation between the molecules increases. Okay, now you got the logic. Okay. So essentially the idea is, let's just write it. As we increase the U, the average separation between the molecules increases. Between the molecules or atoms, whatever it is. Right. Okay, so Aditya says potential energy increase will cause a decrease in separation. So there is not one separation, Aditya. There is not one separation between the molecules. So in a solid, all the molecules and atoms are vibrating. Right? You will study that. You should have studied that in. This is a revision class, by the way. So if you have studied your thermodynamics, you should know that all the atoms and molecules are constantly vibrating about their mean positions. So they have some mean positions about them. They are vibrating like this. So the separations vary between the two molecules due to vibrations. At one point, they are at their closest, and at the other point, they are at their farthest. So when you increase the potential energy, you see the graph also. No, you see the graph. If I decrease the distance, then also the potential energy increases. Does it not? Does it not? So look at this graph. Look at this graph. If you go from U1 to U2, you realize there are two things happening. Okay. Yes, that is what you students don't realize. Okay. That separation decreases also when you are increasing U. So for this U, the minimum separation between the two molecules would have been this. The maximum separation would have been this. So while vibrating, the minimum separation that they would have acquired would have been R1. This value. Okay, this value would have been the minimum separation between the two molecules while vibrating. And the maximum separation would have been this. Now, when you increase the potential energy, both of them will change. The molecules will vibrate more vigorously, first of all, more vigorously, right? Initially, they are vibrating like this, imagine. Now, when you heat it up, they are gaining kinetic energy also, so the vibrations are more vigorous. So when the vibrations are more vigorous, their minimum distance also decreases and their maximum distance also increases. Okay, got it? That is what is happening. So if you increase the potential energy, you realize that the minimum separation decreased, in fact, which you can see from the graph. In the graph, if I decrease the separation from here to here, the potential energy is increasing. And what happens is the maximum separation also increases. Okay, both the distances are changing. But the mean distance, the average distance is increasing. So what is happening is our min is decreasing. That is the minimum separation between the molecules while they are vibrating. Our max is increasing. But turns out this decreases slightly and this increases more, because of which your average separation always increases. If this potential energy curve was completely symmetric, as I told you, if it was a completely symmetric parabola, you would not have seen the expansion. Okay, all right. So that is why materials are expanding. That is the reason for expansion of materials. Okay, if the graph was the other way around, okay, then you would have seen contraction of materials. If I increase the temperature. Anyhow, so that is the reason for thermal expansion. That is the reason for thermal expansion. I wanted you to know that. Thermal expansion is smaller in case of solids, of course, because there the bonds are uh, tighter and the graph is not so widespread. The graph would be tighter again because the energy is stronger between the bonds. So the thermal expansion in case of solids is definitely the smallest, and it is higher in case of liquids. Okay. Now solids can expand. When we talk about expansion of solids, we talk about three kinds of expansions. One is linear expansion. Now there is superficial expansion, which is 2D expansion. And the third one is the volumetric expansion or the 3D expansion. Now liquids and gases usually suffer change in volume only because obviously liquids and gases do not have shapes. Okay, so you cannot have change in areas of them. You cannot have change in lengths of them, right? So you only talk about the change in volume of liquids and gases. So as far as solids are concerned, let's talk about linear expansion. So when a thin rod is heated, its length increases, and this is called linear expansion. So this is called 1D expansion. Now experimentally, we will see that the change in length is directly proportional to the change in temperature. Okay, so why is that? Let's think about this. Whenever you are adding heat, what is happening is, so whenever heat is being added, so your temperature is increasing and your so basically kinetic energy is increasing. I can say kinetic energy is increasing and your potential energy is increasing. Now this can be seen as temperature increase and this can be seen as length increase, right? So the more the temperature increase, the more would be the energy. So the energy goes into both the parts in equal fixed amounts. Okay, for any given material. For any given material, the amount of heat that gets divided into kinetic and potential is always fixed. Okay, that is dependent on the nature of the substance. So higher the temperature change, the higher would be the change in length. So that is the reason. Okay, because the heat provided would be more, so the U is increasing more, so the average separation is increasing more. And then of course it will also be directly proportional to the length. Why directly proportional to the length? Think about this. Why? Because more are the number of molecules, and per molecule, the change in separation that is depending on delta T. Okay, so between every two molecules, the separation increase depends on the increase in temperature. Now, more the number of molecules, more would be the total number of total expansion, right? So I can say what happens is that experimentally it is seen that dl is a directly proportional to l and d theta. Okay, now we introduce a proportionality constant and we can write this as dl equals alpha l d theta, right? If you change the temperature by d theta, then increase in length is dl. Now, interestingly, if you integrate this, what you get is dl over l equals alpha d theta. Now, इसको जरा integrate करो. L naught say L naught being the initial length to final length, and this being theta naught to final theta. What you will get is ln L over L naught. Then L over L naught equals alpha delta theta. What you have is L equals L naught e to the power of alpha delta theta. This is the expression. Okay. Now what happens is that if alpha delta theta is very small, then I use approximation. E to the power x can be roughly written as 1 plus x. Yeah, I hope you know that approximation. For x tending to 0, e to the power x is roughly 1 plus x. So if I use that, then I can write L equals L naught plus alpha delta. So yes, this is the equation that you most commonly use. This is the equation that you must remember. Okay. Or if you take L naught at one side, this is what you get. But please note that this is actually an approximation. This is actually an approximation. However, as far as mains is concerned, you don't need to be bothered about this. You can completely ignore this for mains. This is more relevant for advanced. In advanced, they may ask you something from this. Now, practically, what happens is alpha is usually of the range of 10 to the power minus 5, 10 to the power minus 6. And delta theta on Earth, how much will be the temperature increase? Practically speaking, not more than a few thousand degrees, right? I hope you know that the temperature of the sun is roughly around 6,000 Kelvin. Okay, so 6,000 Kelvin is the temperature at the surface of the sun. So realize that probably on Earth, I will never have a temperature more than that, right? Otherwise, we'll all be burning. Okay, so usually we won't. Okay, so any increase in temperature would practically be a few hundred degrees, or maybe around few thousands. That's about it. So practically, you realize alpha into delta theta actually stays very small. So that is why this approximation works. Okay, so this is relevant for advanced only. So let's just quickly write that. You can currently choose to ignore this, and we can go ahead with these two formulae. Okay, these are the more important ones for our main study. Okay, however, I just wanted to let you know that these are approximations. These formulae are approximations and they only work if alpha into delta theta tends to 0. Okay, now here alpha is known as the coefficient of linear expansion. Alpha was the proportionality constant that we introduced, and that is called the coefficient of linear expansion, right? Now, let's talk about the areal expansion. So again, by following a similar logic experimentally, you will see that the area of any planar object that increases, the expansion is called superficial or the aerial expansion. And again, you will realize by following similar logics, you would have gotten a similar equation. So the equation that you get is delta A equals A naught being the initial area times beta times delta T, where beta is a new proportionality constant that we call the coefficient of aerial expansion. And you can write the final area would have been A naught 1 plus beta delta T. Okay, again, we will focus only on this form of the equation because right now I think most of you would be interested mostly in the mains. Okay, so we won't talk about the E form. All right, then of course you have volumetric expansion, and so when increase in volume of any object on heating is happening, then you call that an expansion, volumetric expansion. The change in volume again would be related to change in temperature like this, where gamma is called the coefficient of bulk expansion. Now, relation between alpha, beta, and gamma is this. This would be very easy to prove, but we are not going to do that because we are revising that. Okay, so when I take this up for class 11, I'll show you all the proofs. I'll show you all the proofs, but not right now. Right now, all you need to do is remember that this is how alpha, beta, and gamma are related. So any one of them is known, you can figure out the other one. Okay. Now, why don't we start with some practice problems? All right. So let's say. So this question says that a scale on a meter, the scale on a steel meter stick is calibrated at 15 degrees Celsius. What is the error in the reading of 60 centimeter at 27 degrees Celsius? So how much error would be there in the reading? So you realize alpha of steel, I told you practically all the alphas are of the order of 10 to the power minus 5. And that is why you can always, that is why your alpha delta theta always remains taken to 0 only. Okay. So just try this quickly and let's see if you can find the answer of this. Okay. All right, people. So let's see if you can get the answer. Come on. Okay. Okay, anybody? Let's see if you guys can figure out the answer. Again, as I keep telling you guys, you have to try the questions. Don't be lazy. Try them. Practice yourself. Okay, this is the last minute time before the exam. You need all the practice. Not only do you need to go over the concepts, you need some practice also. Okay, so definitely try these questions along with me. Okay, so that if you're facing any problem, any difficulty in problem solving, then we can address that too. Okay. So the idea is I want to make sure that you're not only revising your concepts, you are also figuring out whatever difficulties you face in your problem solving, so that we can address that also right away. Okay, so for that you will have to try and you will have to tell me what are the answers that you're getting, and we will have to find out if there is any difficulty with problem solving that you're facing. Okay, so anybody? Okay. Hmm. I guess everybody is feeling lazy. Anyhow. By the way, yes, Merry Christmas. I think everybody is feeling lazy because of the festival time, right? So everybody feeling Christmassy. Is it? All right, all right. So what we'll do is we will try and find the answer ourselves. So I know delta L equals L naught alpha delta theta. That is all. That would be the error, isn't it? Isn't it? That would have been the error. That is all you have to do. L naught is 60 centimeters. So 60 over 100 in meters to alpha, which is 1.2 into 10 to the power minus 5 into delta theta. Delta theta would have been, delta theta was 12, correct? Hmm. Yes, so you're increasing the temperature from 15 to 27. All right, all right. So let's see. What is the answer that we are getting? So I am getting 8, 6, 4 into 10 to the power of minus 7. Okay, that is the answer that I am getting when I did my calculation. Meters. So that would be 864 into 10 to the power minus 4 mm. Yes, or I can say 0.084 m. Let's see if we had that as an option. Yes, we did. So your correct answer would have been A. All right. Okay, I hope you guys followed this. Okay. Right. Now let's move on to the next one. So these are standard questions. These are the kind of questions that are very frequently asked from this topic. Okay, so that is the reason why I want you guys to try all of them. Okay, let's hope you guys tried this at least. So that is a problem. That is a problem, in online. Hmm. That is what I've seen. People, what they do is they start watching the lecture, thinking, okay, today I'll study. But then something comes up on YouTube. They're like, oh, this looks interesting. So they'll open another window and start watching another video. That is how I know. That is why I know you guys are not responding. Some of you probably are busy checking out other stuff on YouTube, which is very very bad. Okay, never mind, never mind. Try and stay focused, people. So here is another question. A second pendulum has a steel wire, and you've been told that the clock is calibrated at 20 degrees Celsius. How much time does the clock lose or gain in a week when the temperature is increased to 30 degrees? So, I have to tell. Let's see. So I hope you know the length of the second pendulum. Okay, some things you should know. You should already know because you this is supposed to be a revision series. Okay, so I'm assuming you know a lot of things. Okay, okay. Anybody? So I'll wait for maybe one more minute and then I'll move ahead and solve this. The guys try to be more participative in this. Yeah, I keep telling you this all the time that I am so used to teaching offline where I get to see my students, where I get to interact with them constantly. So this honestly feels a little weird, staring at my laptop. So without interaction from you guys, trust me, it gets a little weird for me. So try and be more active, participate more. Okay. That'll not only help you, it does help me also. Okay. Okay. Strange enough. Yeah, nobody seems to be trying this hard now. So let's go over the solution. This is very, very simple. I hope you remember. The time period of a pendulum is 2 pi root L over G, right? So here you can say dt over t. I hope you remember your errors would be equal to 1 by 2 dl over L. Correct? Okay. So dt, that is the time that something is losing or gaining, it would be half dl by L into t, right? So now all I need to do is just start substituting the values. I know what a dl by L is. dl by L is alpha delta theta into the time. So for how much time we have to find the error? We have to find the gain and loss in 1 week. Okay, so let's substitute those values. So I will find that dt or the change in time period would be half into alpha, which is 1.2 into 10 to the power of minus 5 into delta theta, which is 10, I think. Yeah, from 20, I'm taking it to 30 into the time in. Hello, Shivam, how are you? The time again is in seconds, so I will try to convert 1 week's time into seconds. So 1 week will have 7 days, 1 day 24 hours, 1 hour 3600 seconds. So this is how I would have gotten this. आज फिर लेट हो गया कोई नहीं It's all right. होता है कभी कभी. I thought a lot of people are seeming lazy. Probably सब Christmas की feel में है. So how's it going with you? तो ये 3 हटा देते हैं और यहाँ से -2 आ गया. And then let's see क्या हो रहा है भाई. What I'm getting is 1.2 into 12 to 7 36 or -2. Now, so let's try and calculate this quickly. 1.2 into 12 into 7 into 36 and upon 100. Okay. So I'm getting 36.3 seconds as the answer. So B is the right answer. Arey, it's all right. It's all right. Yes, Merry Christmas to you too. Absolutely. It's okay. It's okay. सो मैं भी क्रिसमस पे पढ़ा ही रहा हूँ, तुम भी क्रिसमस पे पढ़ ही रहे हो, तो ऐसा कोई बहुत है ना, बहुत अंतर है नहीं हमारे लिए क्रिसमस का, राइट? और अब ये होना भी नहीं चाहिए. फोकस शुड बी आवर टारगेट, आवर गोल. हाँ, जब तक वो पूरा नहीं होता तब तक कोई फर्क नहीं पड़ता यार, क्रिसमस है, दिवाली है, क्या कर रहे हो क्या नहीं कर रहे हो, राइट? ट्रस्ट मी वो जरूरत है. तो दैट्स ऑलराइट, दैट्स ऑलराइट. अच्छा, ये एक इंटरेस्टिंग क्वेश्चन करते हैं. सो लेट्स टैकल अ वेरी इंटरेस्टिंग क्वेश्चन. सो इट सेज ओके. What? Sir, if this time airplane goes from your house, it will drop you gifts. Ah, I wish, Shivam. I wish. So I live very near the airport, actually. I live very near the airport. Okay, so I think barely 2-3 kilometers from my house, I have the airport. So yeah, flights keep crossing my house all the time. But they never drop any gifts, okay? So they never drop any gifts. So all right, all right. So here is another very interesting question. So it says the adjacent figure, it shows a square metal plate. Okay, so probably not square, maybe rectangular. Let's change it to rectangular. This hardly looks like a square plate. So let's call this rectangular metal plate. Doesn't really matter. So adjacent figure shows a rectangular metal sheet with two adjacent circular holes punched into it. Okay, where when the sheet is heated, the variation of the dimensions shown will happen as you've been shown that the size, the length of the rectangular sheet is d. The radius of the holes that have been punched in is r, and the distance between the edges of these holes is x. So when I heat it up, now when I heat this up, what will happen to the different dimensions? So try and find the answer. Option A says increases, R decreases, X decreases. B says D increases, R increases, X decreases. C says D increases, R decreases, X increases, or is it D? D increases, R increases, and X increases. So which one of the following options do you think is correct? So give it a try, and let's see if you can figure this out. So this is a very interesting situation. Okay, so think about this, and try and answer this. Hmm. Okay, let's see. Let's see some answers. Okay. So let me know about your thoughts. What do you think about this? What do you think should be the answer? So go through the problem and think about it. This is a very interesting situation. So let's try and answer. Sushan says, I have a small request. You always take sessions for 2021 aspirants. Next time take a session for 2022 aspirants. We will love to hear from you. So I do take 2022 aspirants sessions also, Baba. We are, I think we are covering gravitation there. We are covering gravitation there. So I do take two sessions for 2022 aspirants every week. Okay, it's just that 2021 is so near, so the focus is more on that. You guys have slightly bit of more time on your hand. You can say S Pandey says D. Hmm. So how about others? Any other thoughts? किसी को कुछ और लग रहा है क्या? So I've gotten one answer from S Pandey, and that is D. Let's see if anybody else thinks otherwise. So go through the answers, go through the options, and see. Acha, guidance sessions. Okay, okay. So what kind of guidance sessions? Yeah, I've seen people love hearing motivational sessions. है ना? Motivational sessions बड़ा चाहिए होता है तुम लोगों को. Okay, plane जा रहा है by the way. I doubt gifts गिरेंगे घर पे. Anyhow, uh, यार एक एक राज की बात बताऊं. जितने भी मोटिवेशनल सेशंस देखोगे, जितने भी मैं यहाँ पे सेशंस ले लूँ, ट्रस्ट मी उसका असर 3 दिन रहेगा मैक्सिमम. ठीक है? आई हैव सीन दिस. है ना? 3 दिन रहता है स्टूडेंट्स पे. क्लास में भी वी यूज्ड टू ऑफन टेक मोटिवेशनल सेशंस, है ना? वी वुड ट्राई टू मोटिवेट आवर स्टूडेंट्स ऑफलाइन इन ऑफलाइन क्लासेस आल्सो. है ना? 3 दिन बहुत हो गया, 1 हफ्ते. दैट्स इट. उसके बाद ना इट फिज़ल्स आउट. जो असली मोटिवेशन है ना यार, वो तुम्हारे अंदर से आएगा. ट्रस्ट मी, कोई बाहर से नहीं दे सकता. कोई बाहर से नहीं दे सकता तुम्हें वो मोटिवेशन. या sort of foolproof strategy for that specific month. हाँ, वही वही आई नो यार. वो जब तक अंदर से नहीं होगा ना, बाहर का मोटिवेशन यार थोड़ी देर सुनने में अच्छा लगता है, थोड़ी देर जोश रहता है, फिर वो चला जाता है, फिजल्स आउट. सो ट्रू मोटिवेशन इज व्हेन यू फील दैट मोटिवेशन फ्रॉम इनसाइड. है ना? नोबडी एल्स फ्रॉम आउटसाइड कैन मोटिवेट यू टू डू द राइट थिंग. ट्रस्ट मी, यू हैव टू फील इट फ्रॉम विदिन. And that is what I feel strange when so many people, so many students just keep wasting so much time after these motivational things. Okay, they'll just make you feel happy for like 5 minutes, 10 minutes. Trust me, after that it fizzles out, and you're just wasting your time. So those who want to do it, do not look at motivational videos of how to do it. They just go ahead and start doing it. Okay, so yes. अरे भाई, I also cried JEE. हमने भी तैयारी की थी. I also was under a lot of pressure. I did not go and watch motivational sessions. I knew from within कि यार मुझे करना है तो करना है, खत्म. ओके, ऑलराइट. देखते हैं. बाकी इसका आंसर किसी और को देना है. Exactly, exactly. Yeah, I was a student myself. The only motivation was I knew for a fact I can crack IIT. That's it. That should be motivation enough. Your self confidence, self belief. You should believe in yourself. कोई तुमको नहीं बता सकता तुम क्या कर सकते हो क्या नहीं कर सकते, ठीक है? तुमको पता है वो, और जिस दिन तुम्हें पता है दुनिया को तुम दिखा दोगे करके, ठीक है? सो ये है बात। सो अपने अंदर से वो जगाओ यार चीज, मतलब डू नॉट लुक फॉर मोटिवेशन आउटसाइड, लुक फॉर मोटिवेशन इनसाइड। Anyhow, so the correct answer, by the way, is in fact D. So very well done, Spondish. So yes, all the dimensions would increase. All the dimensions would increase. See, the logic of that is, when things are heated, then the average intermolecular separation between all the molecules has to increase, right? So for this, it will increase. And here, if you realize, agar to radius chota ho jata, so a lot of people think like that. They'll say, sir, this metal will expand, and this metal will expand into this space. No, it won't expand into this space, because then you realize that the distance between all the molecules which are placed here is actually decreasing. So if X molecules are there, the total separation between them is 2 pi r. So if the r decreased, then the net average separation between these molecules would have decreased, right? Okay. Hello, Arjun Saran. How are you? Okay. Now, similarly, since the average intermolecular separation between all the molecules has to increase, so you will see this also increasing. Okay, so all these three dimensions would increase. Okay, so the correct answer is D. Whenever in doubt, think of it like this. Think of it like this. So you can imagine this square sheet, and imagine you haven't punched any holes. Imagine you haven't punched any holes. Just mark the area. Just mark this area without having to punch a hole. Mark this. Now, if you would have heated this up, all the parts would have expanded, right? So think about this. If I hadn't cut out this portion, right, what would have happened? If I hadn't cut out this portion, then this portion would have also expanded, no? And for this portion to expand, the side portion would have also expanded to make space for this, right? So now you can think of it like this: that the side portion does not know whether this portion has been cut out or not. So it will make space for this portion to expand in any case. That's one way of thinking about this. Okay, so easiest approach that I particularly find is, forget about cutting out the shapes. Instead of cutting out the shapes, just mark the boundaries of the shapes. Okay, imagine you took a sheet of metal, you just marked two circles with a permanent marker, and then you heated it up. And then when you heated it up, see what happens to those markings. Okay, that will tell you the answer. Okay. So that ends our discussion of thermal expansion. Now we will focus on behavior of gases. Okay, so why is behavior of gases so important to us? We briefly study liquids, we study fluids in some detail, but we will study gases in a lot of detail. So there is a reason for that. Now, gases, as I said, is the diffuse. So first, let's introduce the topic, and then okay, Asho. All right. So you are from Tamil Nadu. All right, great, great. I haven't visited Tamil Nadu ever, but I wish to. I wish to someday, definitely. All right. Okay, so as I was saying, so Shivam says, sir, how many of your lectures are required for knowing all the concepts of thermodynamics? Okay, so thermodynamics is a huge, huge chapter here, Shivam. So I think when I will start it for class 11 students, I would take at least 12 lectures, at least 12 to 15 lectures. In here, this is the revision series, so I will try to wrap it up in like 4 sessions. But to talk about all the concepts in details, I think this topic requires 12 to 15 lectures alone. Okay. Anyhow, so let's get started with our discussion of gases. So gases, we know, are the most diffuse form of matter. In a gas, molecules are highly energetic and they are widely separated from each other. So they have hardly any interaction with each other. Okay, so their volume, the volume of the molecules is negligible compared to the entire volume that they occupy. Right. Now, the state of a gas can be usually described by using four quantities. So when we talk about states of matter, okay, so for a gas, different states of existence. So imagine there is a gas in a container, and if you want to talk about the details of what it is doing, okay, what are its features, what are its characteristics, so all its properties can be characterized using four things. Okay, number of particles, the temperature, the pressure, and the volume. Now these three are called the macroscopic properties. Okay, so the gas can be described using these three macroscopic properties. Okay, macroscopic meaning that they are the properties at a slightly bigger level. So if I consider let's say 1 million molecules, so 1 million molecules combined can be defined with this kind of properties. Microscopic would be something on a molecular level, macroscopic on a larger level, larger scale. So on a larger scale, the properties of a gas can be defined using these three parameters. Okay. So the behavior of gases was studied experimentally and is described using various gas laws. So initially people performed a lot of experiments with gases. The reason for that is that gases present you a wonderful opportunity. So you have gases available all around you, and you know that gases can expand to huge amounts when heated, right? So that presents a unique opportunity for me. Okay, in all our things that we use in mechanics, most of the things. So, for instance, if you're talking about a car engine, what is the car engine doing? Okay, so you might not you might not know this. I get excited about this because I am a mechanical engineer. So what happens is that in your car's uh, piston cylinders, what is happening is that the fuel is getting burned. If you have a petrol car, so it's the petrol getting burned. If you have a diesel car, then it's the diesel getting burned. So when that fuel gets burned, it is producing heat and it is essentially expanding the gas in the piston chamber. That expansion is pushing the piston, and that push of the piston is essentially eventually moving your car. So that is what, yes, energy transfer, absolutely, combustion of fuels, absolutely. So it is happening through gases. We are trying to convert heat energy into mechanical energy with the help of gases, because we know gases can expand, and when gases expand, they push things and they can do work. Okay. Yes, we will talk about all that. So that is why gases interest us more, because I know that gases present me a very interesting opportunity of being able to convert heat into mechanical energy. That is why people started experimenting with gases and they wanted to understand their behavior. So why do we understand anything's behavior? That the eventual aim is, if I understand something, I can control it. Okay. So if I understand, how a ball is moving, then I can control the motion of the ball. Then I can throw a ball at any angle. I know with what speed I should throw it to reach a certain point. Okay, so all that I can control. So that's the entire idea of studying the nature and understanding the behavior. Right. So let's see what people did. So first of all, we can classify all gases into two categories, okay, real and ideal. So any gas which strictly follows the gas laws which were experimentally found, yes. So yes, you are right, Shivam. Okay. So any gas which strictly follows all the gas laws is known as ideal gas. In a real, the behavior of the gases obviously is different from the expected ideal behavior. That is because we make a lot of assumptions while devising the ideal behavior. Okay, so those assumptions do not hold true in real life. So, however, their behavior tends to be close to ideal behavior, ideal gases, and two conditions. So, under at high temperatures and low volumes, we notice that even real gases in these conditions behave pretty close to ideal gases. The behavior of ideal gases helps us understand the behavior of real gases, and that is why we study the behavior of ideal gases for two reasons essentially. One, it will help us understand the behavior of real gases. Second is it is the easier one to understand. Okay, so at your level, it's just easy to study. All right, so let's quickly talk about the gas laws. Okay, so these were the gas laws which were formed by a lot of experimentation. So you had Boyle's law. Boyle's law essentially says that according to this law, for a given mass of gas at the volume of the gas at a constant pressure is inversely proportional to the constant at constant temperature. That's what I was thinking. Something wrong. Uh, that is what Boyle's law is. P inversely proportional to V. At a constant temperature, the volume is inversely proportional to the. You too a fan of mechanical engineering? Yes, I can see that. I can see that. Okay. So that is what Boyle's law tells you. The graph between P and V at constant T can be seen like this. Okay, and that is the mathematical equation. So this most of you would have studied in your chemistry also. All right. So this is Charles' law. Then Charles' law says that at constant pressure, the volume is directly proportional to temperature. Again, graphically, you can see it as you know you would have drawn this here. You would have studied this also again. So we'll just quickly move over all these laws. So it says studied automobile manuals of elder brother and stolen from his library. Okay. I hope you did not catch beating doing that. All right, so this is the equation of Charles' law. This is the equation of Boyle's law. And then, of course, you have the pressure law. This is the equation of pressure law. This is for constant volume P is directly proportional to P and so on. Okay, then finally, if you combine all these laws, then you know that P into V is directly proportional to N times P, and you have this equation which can be written like this and like this. Okay, this is called the ideal gas equation. Okay, where R is the universal gas constant and has an SI unit value of 8.31. Okay, so again, this is just a quick recap. This I'm sure you would have studied all along in any case. Now then there is Avogadro's law. Avogadro's law says that the number of molecules per unit volume is same for all gases at a fixed temperature and pressure. That is very interesting. Okay, per unit volume, every gas has exactly the same number of molecules. So that was something really interesting. At STP being the standard temperature and pressure, okay, 22.4 liters of gases have these many molecules. Okay, and this is what you call Avogadro's number. The mass of the molecules equal to Avogadro's number is called the gram molecular mass of the gas. The value of R in Cal 2, please. Horsepower conversion to joule. So we will come to that. Come to that. In calories, I think it's 2. If I remember correctly. I usually don't remember too many values, but I think it's 2 in calories. R is around 2 in calories, wala units. Okay, you can Google that up. I hate memorizing those values. Horsepower to joule conversion is simple. Okay, so 746 joules, 1 horsepower. It's around this 746 or 748. I get confused about this, but it's somewhere around that number. Okay. So again, you can Google all these values. You don't need me for these values. Okay. These are numerical constants, so you can simply look up. All right. Now let's have one small quick problem, okay, and then we will wrap up today's session. We will carry forward the discussion over in the next class then. Okay. So this says that electric bulb of volume 250 centimeter cube is sealed off at a pressure of 10 to the power minus 3 mm of Hg at 27 degrees Celsius. Compute the number of air molecules contained in the bulb. So this is a very simple application of PV equals nRT. So N would be equal to PV over RT. That just substitute the values and you would have gotten the answer. Okay. These are very standard, straightforward questions that you'll be asked from these gas laws. Okay. So trust me, nothing much to worry about here. This is one problem that you can try as your homework, okay, because we have run out of time for today. So that is why I would like to wrap it up for today then. So before I take your leave, let me remind you that if you haven't gotten your plus subscriptions, then this is how you do it. So go to the plus section of the app and select your goal as IIT JEE and click on the get subscription button. When redirected to the payment page, use this code RD Live in this box, which will say, "Do you have a code?" Tell them yes, you do. Okay, RD Live that would be that code, and this will give you a 10% off on all your subscription fees. Now you can choose from 2 kinds of subscriptions, Plus and Iconic. And also, when you click on Proceed to Pay, you will realize that you have a lot of no-cost EMI options available. Trust me, even these payments you won't feel the pinch due to these payments. You can choose any no-cost EMI option that suits you. Okay. With that, let's tell you a bit about the Iconic subscription quickly. So this iconic subscription is something which will take your IIT JEE preparation to the next level. You will be allotted personal coaches. Yes, that is today only, Shivam. That is today. I hope you realize. Today is Friday. Okay. So at 6:30 you'll have that class today. Iconic subscription is something which will take your IIT JEE preparation to the next level. Why and how does it do that? You get assigned personal coaches which closely mentor and personally guide you through your IIT JEE journeys, and you get some extra benefits also. Okay, like this. So again, another a great chance of winning yourself this subscription is this taking part in the Unacademy Combat. You can enroll now for the next event, which is happening on the 3rd of January. Use the code RDLive to enroll, do well, and win yourself some cool prizes. Use this code, you get a gift from Santa. Yes. Okay. Maybe. I don't know. Again, if you like today's lecture, then don't forget to press the like button and share it with as many people as you can. Okay. So let more and more people get the gift of quality free education. That is our gift on Christmas, or rather throughout the year. We guys do not wait for Christmas. We are giving away this gift of free quality education all across the year. So make sure more and more students are receiving this. Okay, so share it. Don't be selfish. And if you're new to this channel, don't forget to subscribe and don't forget to press the bell icon. Okay. PDF of all the slides used in today's lecture will be available for download very soon. Those of you following us on the JEE English channel on YouTube can connect with us on the Telegram app using this link so that you are receiving all the timely notifications of all these sessions and lectures happening over on this channel. That is where I would like to take your leave. So Merry Christmas all, and have a little bit of fun. And of course, with that, I will see you in the next class tomorrow where we will carry forward today's discussion. Okay. Before I leave you, one more time, Merry Christmas, and of course, how can I forget about this? So this is my code RD Live. If you're planning to get your Unacademy subscription, you can use this code and get a 10% off on your next subscription. All right. With that, you guys take care. Enjoy.